Hey, geometry. All right, so we are going to do my video. My video. We're returning to proofs. All right, I'm just going to come right out and say it. Test for parallelograms, rectangles. I don't know if we're going to get to rectangles. Let's see. But I know this. We're returning to proofs. Okay, and why is that? Because inside of quadrilaterals, we find triangles and transitive properties and other things. Okay, and so not only that, but geometry is all about finding missing things and identifying relationships that exist. And that means proving things so that we can measure the previously unmeasurable, Write a two-column proof that parallelogram HJKP and parallelogram PKLM are in those. HJ is congruent to ML. So we're given two parallelograms. And before geometry class, you might say, well, that's nice. But now, hopefully you say more than that. Hopefully you say, ooh, because I have two parallelograms, I have a whole list of properties that I can use in my proof. Opposite sides are congruent. That's 6.3. Wait a minute, 6.3. Do we even, I'm going to go back to 6.2. But also, the opposite angles are congruent. Theorem 6.4. Our consecutive angles are supplementary. If there's one right angle, it has 4. What else? 6, 7. Its diagonals bisect each other. It splits into two congruent triangles. 6, 8. So I mean, we got a whole list of tools in our toolbox to prove that HJ and ML are congruent. This one, when I'm thinking about my proof plan, I'm thinking, all right, so these are sides, right? And that's what we want to prove. We want to prove that this is congruent to this. But we can't say that yet because we'll have to say that at the very end. What we can say is our given is that we have parallelograms. And we're talking about sides, top and bottom. So I wonder if you can see what I can see. They're both connected to PK. HJ is congruent to PK because opposite sides are congruent. Alternatively, PK is congruent to ML because opposite sides are congruent. And if they're congruent to the same thing, then you know by transitivity, they're congruent to each other. So the plan is to use the transitive property just like they did in the example. Okay, so let me just make a little table here. All right, so given, there's my given. Number 2, moving on. HJ is congruent to PK. And what theorem is that? Is that 6.3? If you can remember the theorem numbers, it's 6. I remember the theorem number. Isn't that good? Theorem 6.3 in the text. Then I can just write theorem 6.3 for my reason. Nice and easy. And guess what? PK is congruent to ML. Also by theorem 6.3. And they're both congruent to PK. So now I can just say that HJ is congruent to ML. Transitive property of congruence. TPC. All right, so you got some, where'd they go? You got some proofs here to try, and you're gonna see them on the quiz next week, first week of February. This quiz, Alabama's flag, Think of the two congruent triangles, CP, Well, lots of proofs. I would suggest trying those proofs. Okay, so now we're going to talk about tests for parallelograms. Give you a few more theorems. So, conditions for parallelogram. So this is if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So just pause for a second and realize something. In this section, the given is not that we have a parallelogram. But what I just read before, the given was we had parallelograms. When we had parallelograms, we could use theorem 6.2, 6.3, 6.4, 6.5. All of those were reasons because we had parallelograms. But in this section, we have quadrilaterals with some properties, and they may or may not be a parallelogram, even though they really, really, really look like one, like ABCD does there. You have to prove it, okay? So this is one theorem we can use to prove it. If it has opposite sides that are congruent, it is a parallelogram. If the opposite angles are congruent, it is a parallelogram. If the diagonals bisect each other, it is a parallelogram. And if one pair of opposite sides is both parallel and congruent, it is a parallelogram. All right. So some of these questions are going to seem exactly like the ones from the other section, 6.2, because you're just using those properties. So even though it's backwards, it won't seem different to you. So it says determine whether it's a parallelogram. Well, we see opposite sides are congruent, so we can say yes. Opposite sides are congruent. How about this one? One pair of opposite sides are congruent, and one pair of opposite angles are congruent. But we can also use we know that quadrilaterals add to 360. Wait, hold on now. Can we say that? We need both pairs. We need both pairs of opposite angles in both pairs. So I don't think we can say this. No, it doesn't fit any of our theorems anyway. All right. An example at the beginning of this lesson, explain why the cuts made by Lexi and Rosalinda are parallel. Where Lexi and Rosalinda cut strips of bulletin board paper at the angle to form the hallway display. Their friend asked them how to cut the strips so that their sides were parallel without using a protractor. Rosalinda explained that since the left and right sides of the paper were parallel, she only needed to make sure that the sides were cut to the same length to guarantee that the strip would form a parallelogram. Well, there you go. Good job, Rosalinda. What theorem did she use? Saying that the sides were parallel and congruent to make sure they're the same length. She used theorem 6.12. All right. So that was that. Now here, if the quadrilateral is going to be a parallelogram in 3A, then the opposite angles have to be congruent. And if the opposite angles have to be congruent, then we can write 56 has to equal 7x, and also 5y minus 26 has to equal 4y plus 4. So you can solve those. And that will be fine. Work out. Same thing here in this one. Just set them equal. And then you'll know the value of x and y that makes them a parallelogram. Okay, so make sure you have the concept summary in your notes. And we have some coordinate geometry. We're gonna do coordinate proofs on another day. We're gonna show you that we're going to do coordinate proofs on another day and jump to rectangles. I'm going to go back and do coordinate proofs. Let's jump to rectangles right now. Properties of rectangles. A rectangle is a parallelogram with 4 right angles. By definition, a rectangle has the following properties. All 4 angles are right angles. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. Okay, why is that? Why does the rectangle have these properties? I mean, I read it. Because it's a parallelogram. Those are all properties of a parallelogram. But in addition, we have theorem 6.13, extra properties of the rectangle that not all parallelograms have. Its diagonals are congruent. We cannot say that about, just some average parallelogram, which need more space to draw. This diagonal is much shorter than this guy. Diagonal is not congruent, but in a rectangle, the diagonals are congruent. So we can easily make a nice rectangle with that. So TS equals 120. Find PR. TS is 120. So then what is PR? Okay, you might say, okay, we're going to do that. So that's 120. But we know this. We know that diagonals bisect each other in a parallelogram. So they bisect each other in a rectangle. So this is also 120. And this is also 120. And this is also 120. And so PR is 2 120s. So that's 240. At PT plus TR. All right, if the measure of angle PRS is 64, PRS is 64, find SQR. SQR right here. So this is 64. Then what is SQR? Well, we know that this is 64 because they're alternate interior angles. And then also, I mean, there's so much that we know that we could say. I need to erase a little bit. Okay, so for this angle problem, we know that this is 64. We know that this is 64 because that's an isosceles triangle. And then the two 64s means that the top has got to be 52, which means that this is 52. Oh, and these are both 64. There you go, 64. So 64. All right, that was one way of showing it. There are other ways as well. Moving on. Refer to example 2. If JP equals 3y minus 5 and MK equals 5y plus 1, find y. So what do you think we're going to do? JP, 3y minus 5. Let's put that in the picture. And MK is 5y plus 1. All right, so we know that JP, 2 JPs is 1 MK. So you write that. 2 JP equals MK. Because MK is the whole diagonal, JP is just half. So now, substitute in. And then distribute. And then put our variables on our left, numbers on the right. Oh, I'm done. is 6y minus 5y is y. Catch that. I added 10 to both sides. Okay. So that was guided practice number 2. Prove. Uh-oh. We have to prove something. And then we're not doing the coordinate geometry right now, but we will come back to that. It's very important. Okay. Diagonals of a rectangle of a parallelogram congruent, then the parallelogram is congruent. Then the parallelogram is a rectangle. Yeah. Okay. So, last example. Set design. Refer to the beginning of the lesson. Leonardo measures the sides of his figure and confirms that they have the desired measures as shown. Using a carpenter's square, he also confirms that the measure of the bottom left corner of the figure is a right angle. Can he conclude that the figure is a rectangle? Explain. All right. Come on, Leonardo, you got this. Mr. Field, you got this. Okay, so he knows that he used a carpenter's square. So he measured the sides, and so do we know that this is a rectangle? Well, we know that if a parallelogram has one right angle, it has 4, right? So, and we know that a shape with 4 right angles is a rectangle, right? So we could say, isn't that true? Isn't that theorem 6 point something something? If a parallelogram has one right angle, don't worry, we're not going back. No need to go back. If a parallelogram has one right angle, then it has 4 right angles. Well, now that we're talking about rectangles, we can say, and it is a rectangle. Theorem 6.6. All right, don't forget to do IXL and 6 through 10, and I will see you in class. I didn't take so long in this video.